lesson should be a bit shorter than yesterday's. I apologize for the length of that yesterday. It did seem to carry on a bit, but we had a lot to cover for a section of a chapter. That happens sometimes. Today we're going to look at what happens with these angle pairs when the lines being crossed by the transversal are parallel, which is going to be our case most of the time when we're dealing with these types of problems. So now our two lines, in this case P and Q, oh, I still have my orange highlighter from yesterday, cool. My two lines P and Q that are being crossed by a transversal are now going to be given as parallel lines. And again, we can see that indicated with the symbol there for parallel lines. So now interesting things start happening once these lines become parallel. And basically it boils down to this. We get a lot of the angle pairs being congruent. In fact, the corresponding angles wind up being congruent. The alternate interior angles wind up being congruent. And the alternate exterior angles, all those pairs wind up being congruent pairs. So once again, like we talked about before, know the name of the angle pair and the relationship. The name would be corresponding angles. The relationship would be, if the lines are parallel, then the corresponding angles are congruent. Same with theorem 3.2, alternate interior angles. If the lines are parallel, the alternate interiors are congruent. If the alternate exteriors, if the lines are parallel, the alternate exterior angles are congruent. The one that's an exception here are the consecutive interiors. The consecutive interiors are not congruent. The consecutive interiors are supplementary. Now, we can work on memorizing this stuff, or we can just use some plain old common sense. In most cases, as long as my transversal is not nearly perpendicular, if my transversal is at a decent angle, I can just look at this picture, and if I know that the relationships are going to be, let's get our little triangles on there to indicate parallel lines, okay? But if we just look at this picture, we can see I've got four acute angles and four obtuse angles. Well, an acute angle is not going to be congruent to an obtuse angle. That's only common sense. But guess what? All four of those acute angles are congruent, and all four of the obtuse angles are congruent. And if I'm looking at a consecutive interior pair, which might be this angle and this angle, clearly they are not going to be congruent. One's acute and one's obtuse. So my other choice is they have to be supplementary, adding up to 180. So when I got parallel lines here being crossed by a transversal, any angle pair I pick is either going to be a congruent pair or a supplementary pair. Because all the linear pairs are supplementary, all the vertical angles are congruent. Now we have all the alternate interiors are congruent, all the alternate exteriors are congruent, all the corresponding angles are congruent, and the consecutive interiors are supplementary. So all sorts of different things going on. And again, this is one of those places where those flashcards you made yesterday, now you might want to add information to them about, oh, now the angle pair is congruent or the angle pair is supplementary. Add information about the relationship. But if you don't have it memorized, look carefully at the picture, analyze what's going on, and it should be pretty obvious in most cases what the relationship is. The only time it gets at all tricky is if my parallel lines being crossed by a transversal, if that transversal is nearly a right angle. Okay? Then it can get a little bit tricky because it's not quite so obvious what's obtuse and what's acute. By the way, if it crosses at a right angle exactly, guess what? Then all the angles are congruent because they're all right angles. And they're all supplementary because they're all right angles. So right angle is a very special case. Makes problems that we deal with fairly straightforward. We're going to do one of two things with our angle pairs. We're going to set them equal to each other, or we're going to add them up and set them equal to 180. We just got to figure out what to do. This should sound very familiar to T. We've been doing this a lot. Here it says, what other angles have to be 120 degrees? Well, all the obtuse ones, right? We don't even need to know the angle pair names to figure this out. All the obtuse ones do. So that would be angle 4, angle 5, and angle 8 are all my obtuse angles. Those would be the ones that have to be 120. Now we could justify some of this. Angle 5 has to be 120 because angle 5 and the 120 degree angle are corresponding. Angle 4 has to be 120 because the angle pair is vertical. And angle 8 over here has to be congruent to 120 because they are alternate exterior. So we can explain it using our theorems. But again, if all we're asking is which ones, it should be fairly obvious as to what's going on. As usual, we're going to be doing problems like this. Find the value of x, set up and solve the equation. So we have to decide what is the relationship between the angles. Now, here we have a little bit of a quandary because the 115 and the x plus 5 are not a named angle pair, are they? One's exterior, one's interior. They're on alternate sides. They are not corresponding. They are not at the same intersection. That's not a named angle pair. I don't technically have a relationship for that. But I know the 115 and the angle 4 are vertical angles, which means angle 4 is also 115. And therefore, the 115 and the x plus 5 is what type of an angle pair? Let's think it out. They're both interior. They're not alternate sides. They are on the same side. So consecutive interior, and consecutive interiors have to be supplementary, according to my theorem. Or I could just look at it and say, this one is obtuse, this one is acute. They aren't going to be congruent. So 115 plus the x plus 5 is 180. Combining terms, I get 120 plus x is 180, and subtracting the 120, we very quickly get to x equals 60. Now we ask ourselves once again, is that my final answer, or do I need to find the measures of the angles? And in this case, find the value of x is the instruction. We're done. Same here. Again, I don't have a direct relationship because that angle pair both are exterior, but they're on the same side. We do not have a theorem for same side exterior angles. We could probably make one, but it's really not necessary. Common sense tells us probably one's obtuse, one's acute. They aren't going to be congruent. Since the lines are parallel, we can conclude they must add up to 180. We could also go and say, well, if that's the case, if this is 130, so this is one way we could do it. Let's finish this out. 145 plus 7x equals 180. So 7x is 35. So x is 5. That's fine. The other thing we could do is say, oh, wait a minute. Angle 1 and the 136 here are a linear pair, which means that they have to add up to 180. Well, if that's the case, that means that this angle has to be 44. And then I could go, 44 equals 7x plus 9. Alternate exterior angles have to be congruent. Subtract the 9. Guess what? I have exactly what we had before. Still works out. So there's often more than one way to attack these problems if we do not have a direct relationship. I mean, I could have worked with this angle down here as well, angle 2, and said, okay, these two are a linear pair. This is 44. Now I have corresponding angles instead of alternate exterior. A lot of ways of going about these things. Again, this is pretty much a common sense situation. go ahead and set things up, solve them out. We'll just look at number 2 here for the moment. It says if M angle 3 is 68. Okay, so that angle is 68 degrees. And M angle 8 is 2x plus 4, so we got angle 8, 2x plus 4 degrees. What is the value of x? Show your steps. Well, again, 3 and 8 don't necessarily have a direct relationship. But that's okay. I can see that one is acute and one is obtuse. They are parallel lines. So if they are not congruent, they're going to be supplementary. So I would just do 68 plus 2x plus 4 is 180 and show my work. So 2x is 108, so x is 54. And again, the question asks, what is the value of x? It does not ask the measures of the angles, so we may stop at that point. One interesting application of this, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. Little physics for you. For violet light, the measure of angle 2 is 40 degrees. What does the measure of angle 1 have to be? So the measure of angle 2 and the measure of angle 1. What type of angle pair do we have? Now here's a little something that can help us identify our angle pairs. All right, what letter do we see? It's kind of backwards, but what letter do we see here? It's a backwards letter, but it's a Z or an N if you twist it. When I put those two angles together, they make a Z. When I see that letter Z, I have alternate interior angles. Some people like that. Some people go, oh, it's a Z, alternate interior. That's good. Corresponding angles, you'll notice, if you have a pair of corresponding angles, what letter do we have? Now, again, this is flipped around, but that's okay. Corresponding angles make an F. Consecutive interior angles make a C. So sometimes you can tell what's going on based on what letter do you see. When you look at the picture and you draw out the two angles, what letter do you see? I see a Z. Oh, alternate interiors. Oh, I see an F. It's kind of flipped around upside down, but it's an F. Oh, that's corresponding angles. Oh, I see a C. So that's consecutive interior. Alternate exterior really don't make a letter. So, but just a way for some people, not everyone's going to use that, but for some people that just helps it click. That helps you remember what's going on. Okay, and again, what do we notice about these angles? We really didn't answer the question, but it's a Z. They're alternate interior angles. They have to be congruent. Measure of angle 2 is 40 degrees. Measure of angle 1 also has to be 40 degrees because they're alternate interior angles. And so if measure of angle 2 is 41, then the measure of angle 1 must also be 41. Again, because they are alternate interior angles, parallel lines crossed by a transversal, the alternate interior angles are congruent. All right, I think I've gone on long enough on this today. Please take notes, work on those flashcards, and we'll see you.